So last time I showed you how to create a static texture using a 3D shader. So you can see that the texture does not change when the character is animated. But in my case, I wanted to render this 3D texture onto a flat 2D texture so I could use it in the material 3D. And I'll be using this for procedural skin generation, so there's many layers and different effects. So it would be quite intensive to be running the shader all the time. It would make more sense to just output it, to basically bake it into a flat single texture and save it in the material. So I'll go ahead and show you how to do that. So here I've got just the mesh skeleton and the animation player, along with a simple tool script that just updates whenever you hit the toggle. So this is typically how I test in the editor, makes it easy. So first I'll make a new mesh instance 2D to render the texture onto. And then in the update function, you'll need to define the target size. So this will be the size of the image, which is a vector 2. I'll make it 1024 by 1024. And then you'll want to get the 3D surface arrays from the 3D mesh on surface 0. And then I'll make a new variable for the 2D mesh arrays that will go here. So first you'll need to resize the array to the maximum size, and then I'll set the vertex array to a new packed vector 2, since it's a 2D mesh. And then basically you just want to transfer the UVs onto the 2D vertex. So you'll just draw the triangles onto the texture, but the UV is between 0 and 1, so you'll need to scale that by the texture size, basically. So I'll loop over the UVs from the 3D arrays, and then I'll set the vertex of the 2D array to the UV times the target size, so you can actually see it. Otherwise it'd just be like little bitty. And then the index array will be the same for both, so set that to the 2D to the 3D index. And then I'll go ahead and make a new array mesh and add the surface from arrays. I use triangles and pass the 2D arrays in. And then finally I'll set the mesh instance 2D mesh to the mesh 2D. So now if I click on the mesh instance, it's blank, but if I run the update function, there you can see that the texture UVs have been filled in, so you can see the hands and the feet and all that here. So that is how you create the mesh. But now we just need to add the texture. So now we'll want to add a shader material to the mesh instance 2D. We'll make a new shader and So you can access the position using the vertex, and so if you just do that, it'll be white because the vertex is over 1. So you'll want to divide by the image size. And now you can see we have a gradient pattern based on the 2D position in the UV map. So that is pretty cool. And then, so now if we want to use this texture for our mesh instance 3D, I'll need to add a sub viewport and put the mesh instance 2D underneath it. And so you can see that it is only 1/4 of the actual size, which means you'll want to set the size here to your target size, which you'll do through the code. But so now you can see that the viewport has the entire array mesh here, and you'll probably want to enable transparent background as well, just for later, like so. And now with the mesh instance 3D, you can make a new standard material and set the albedo texture to a viewport texture. Oh, you need to make the resource local. And then you'll assign the sub viewport. Alright, so now you can see that the texture is now on the 3D model. Very cool. So, but you notice right away that there are obvious seams because, of course, we're going from a 2D space to a 3D space, so the edges aren't going to wrap around, which is why you have to use the 3D coordinates to generate your texture. You can't just use the 2D UV coordinates, but as we did last time, we can just inject those, so I'll go ahead and do that. So in the script, you'll need to set the custom 0 equal to a new packed float 32 array. And then I'll loop over the array size, set the UV there. This way we don't have to loop over more than once. And then in the, basically I'll just append the 3D vertex locations into the custom 0 array. So, and this is how we inject additional data into a shader. So there are 3 or 4 custom channels, and you can put up to 4 floats per vertex in there, which is pretty useful. They do have to be appended individually, so the X, Y, and Z. You do not enter it as a vector. And then at I, you need to specify the vertex. And then down here, I'll set the flags value. So this is mesh array custom RGB float bit shift the array format custom 0 shift. So this shifts the array over by 3 for the R, G, and B, not the A. And then in here, when you add the service, you'll pass the flags as well. So this is how you inject data into the custom 0, like so. So now in the shader on the mesh instance 2D, I'll need to define the local vertex varying like we did in the previous example, and then set the local vertex equal to the custom 0.xyz inside of the vertex function, and then inside of the fragment function I'll set the color.r equal to local vertex.r, G and B. Okay, and it is all black because I haven't actually injected the custom 0. So if you go there and hit update, now you can see we've got some color. Now of course the colors are restricted from 0 to 1, so the majority of this model is outside those bounds. So I'll go ahead and add 0.5 to the R and B and divide the G by 2, just so you can see that it is now a 3D texture and it does wrap around the back correctly. You can see on the neck. So it's all a smooth gradient now, based on the model's 3D position, and it is being rendered into a flat 2D image, as you can see here. So that was the goal. Now there is the issue here with the seams, as you can see. So I'll go ahead and fix that, and then I'll show you how to actually save this as a resource instead of rendering it, because we're still rendering it, which is of course counterproductive. So to get rid of these seams, you'll just need to fill in the edges around the UV map that we made. So you'll need to access this texture and make a new shader. You can either use a sub-viewport container, which is what I do in Humanizer, or a texture rectangle. Just make sure that it's after the sub-viewport, and then you'll set the texture to the sub-viewport, or it'll just be a child of the sub-viewport container, either way. And then I'll need to add a new material to this. So we'll make a new shader, fill seams. Alright, so first we'll need to declare the uniform int margin variable. So this will be how many pixels to grow the edge. And then don't need to do anything in vertex, but in the fragment, we'll say if the color of the current pixel, so the texture rectangle shader will look at every single pixel. The mesh instance only looks in the pixels within those triangles. So depends on what you need to do. So we're going to say if the pixel of the alpha of the pixel is 0, so if it's completely transparent, then we'll need to fill that pixel in. So we'll say the closest pixel is at -1, -1. The values will be between 0 and 1 because it's a UV value. So if I set it to -1, it will always be at least the maximum distance. Alright, and then to get the pixel size, so I found this on Reddit. but you just get the divide the texture size, divide 1 by the texture size to get the pixel size. And then we'll say for x equals negative margin, x is less than or equal to positive margin, x plus plus, and then do the same thing for y. So we want to loop around the pixel by the number, by the margin on each side, essentially. And then we'll be getting the closest pixel in there. So closest valid pixel. So we'll say the pixel offset is a vector 2 of the x and y. And this is happening for every single pixel. So, and then I'll get the offset UV, which is the UV plus the pixel offset times the pixel size. So that will get the and then we'll get the color at the offset. So UV color equals texture at texture, and then the offset UV. So now we'll find the color of the pixel, and then you want to check if the offset UV color dot alpha is not equal to 0, and the distance between the UV and the offset UV is less than the distance between the UV and the closest pixel. Then say the closest pixel is equal to the offset UV. What did I do here? Oh. Okay. And then, so this lines up here. I think I need another, there we go. So then, I want to make sure if the closest pixel dot x is greater than equal to 0, so that'll get rid of the negative ones here. Then the color equals the texture at the closest pixel. So, oh, and look at that. So if I click on here and can see by changing the margin, nothing happens if it goes under, but by changing the margin here, you can see that it is in fact growing the seams. So that is very, very cool. Very, very useful. Like I said, Blender has a similar functionality. So this is interesting though, when you zoom in or out, it actually messes it up. But when it's at 100%, this does work, and it actually won't be rendered. That's the whole point of this, is to do this in the background and just generate a flat image. So you will, yeah, it'll be 100%. So now to get this on our mesh here, see we still have the lines. So I'll go ahead and add another sub viewport and then move all of this under here, set the size like that, and then we'll update our viewport texture on the mesh to the second viewport. And voila! Look at that. We have now gotten rid of the seam. So, that's pretty much what you have to do. And now we'll go ahead and save it real quick as an actual image. So now, in order to save our seamless texture, which looks pretty good, I think. So you'll want to save this as a flat image in the code. Set that. Alright. And then you'll await the rendering server post draw frame, and I'll get the material equal to the mesh instance 3D surface material override. And then we'll get the new image, which is the sub viewport 2. So here you can see the original and then the one with the expanded seams. So we'll get the sub viewport 2 dot get texture get image, and then I'll set the material dot albedo texture equal to image texture create from image, and then use the new image. So you could also save this to a PNG here in the code. So now if I update this, it looked like nothing changed, but if you go here to the mesh instance, so this is now a image texture. Before it was a viewport texture, but now we've captured an image of the viewport in a moment of time, and now this is static. So you can actually save this as a compressed resource, or if you want, you can save it as a PNG through here as well. So you can open it with a regular image browser. So there you go. That's how you can transfer your 2D or your three-dimensional shader textures onto a flat 2D UV texture, if that's what you would like to do. So like I said, I'm using this for procedural skin generation. So you'll have one layer of colors, one layer of freckles, one layer of age lines, so on and so forth. And I believe it would be more efficient to simply save the textures as an image, but I don't know. Maybe. So the idea here is once you've generated the static image, then you'll remove the sub viewports, however many you have stacked up, from the scene, and the mesh will keep its texture, basically. So I have a service that renders those viewports. Well, it doesn't render them. You have to add them to the scene tree, but then it cleans them up once it's done and exports that image. So anyway, it's pretty cool. Let me know what you think, and have a great day.